Okay, so for today's video, I wanted to go ahead and go over another type of factoring that is going to be very, very important when we get to the polynomials unit in our study. So right now, what we have been doing is really just focusing on different types of factoring methods. And today I wanted to go over another type of factoring method that is definitely going to help us out in the near future, and that is factoring by grouping. So this method of factoring isn't too complicated. We just have to be a bit more careful about how we factor out certain terms in our expression. So let's go ahead and look at these two examples for today. And once again, the main idea for today is to be able to factor these types of examples by what we call grouping. So let's go ahead and jump right into it and see what that means. So for part A, once again, they wanted you to go ahead and factor by grouping. So let's look at part A. Please notice in part A, this expression that I gave you has 4 terms in the expression. And that is very important to notice, because if an algebraic expression has 4 terms, then if they tell you that they want you to factor, one helpful way we can know how to approach this type of factoring is to use the factoring by grouping method. So notice that in this example, once again, you have 4 terms. So here's the idea. Let's go ahead and rewrite this expression I gave you. And here's what we're going to do. So what we're going to do is we're going to group the first 2 terms here together. So to show that, this is what we'll do. So we'll say that is equal to parentheses x cubed plus 4x squared. So we group these first 2 terms together, and then we'll group the last 2 terms together. So plus parentheses 3x plus 12. Okay, so at this point, once we've grouped these terms together, here's the idea. You want to find, here's the key idea. You want to find a common factor from each grouping. So if we look at this first grouping right here, notice that both of these terms have an x in them, but they both share an x squared here. So technically, here's what we have. We have x squared times x plus 4x squared. Let me just rewrite this other one. So if you want to be real technical here, we can break this x cubed apart and rewrite it as x squared times x based on our exponential rules. So from here, we can see that this term has an x squared and this term has an x squared. So we can factor this x squared out. So let's go ahead and do that. Equals x squared. When we factor out the x squared from here, you're left with x plus 4. So once again, we factored out an x squared from this grouping, and we get this expression from here. Now let's go ahead and focus on the other grouping right here. Notice that these terms do not share an x with each other, so we can't really factor out anything with a variable, but we can definitely factor out a number that they share in common. So here we can factor out the 3 from this grouping. You get plus 3 parentheses. If you take out the 3, you're left with x. And then you have to ask yourself, 3 times what is equal to positive 12? Well, in this case, 3 times positive 4 will give you positive 12. So there you go. When we looked at this grouping, all we did, once again, is factor out the 3. And then now we're left with this expression right here. Notice that in this expression, you have an x plus 4 and an x plus 4 over here. So let me just highlight that. X plus 4, x plus 4. So because this term and this term share the same term of x plus 4, we can go ahead and then factor out once again this term from each of these. So that'll be parentheses x plus 4. So x plus 4 is coming from this. If you remove an x plus 4 from both of these, you're left with this right here. Let me just be clear. You're left with x squared and plus 3. And we'll enter these in over here into this other expression. So in this inside, you're left with x squared plus 3. And there you go. We factored by grouping in this example. So this would be your final answer for part A. So once again, if we look back at part A, we went from this expression all the way to this factored expression using factoring by grouping. So let's go ahead and go over one more real quick. So in part B, let's do the same idea. We just have to be a bit more careful in this one. So let's rewrite it. Okay. So let's group all the terms. Let's group the first 2 terms and the last 2 terms together. So we'll have x cubed plus 5x squared. Here, notice I'm going to put a positive here, and then I put a parentheses minus 2x minus 10. So I'm just making that separation with a plus sign in the middle. So just keep that in mind. So once again, if you notice here in this grouping, they both share an x squared. So you can factor out the x squared. And then similarly to the previous example, you would be left with x here. Because x squared times x is x cubed. And then we remove the x squared here. You're just left with the plus 5. And then in the other grouping, that doesn't have any variable you can factor out, but you can factor out a number from here. Here, what I recommend is if you have a negative in the situation, I would factor out the negative with the number. So here we can factor out a negative 2. We can factor out a negative 2 from here. So that negative 2 we'll put on the outside. And you're just left with x. And then here, negative 2 times what is negative 10? Well, that has to be a positive 5. And notice by doing that, by factoring out this negative, we were able to now have a common term of x plus 5 in both of these groupings that we made. So from here, we can go ahead and factor out the x plus 5. So x plus 5 goes there. If you remove the x plus 5 from this grouping, you're left with x squared. And then if you remove the x plus 5 from here, you're left with x squared minus 2. Okay. So we'll go ahead and stop right here. This would be your final answer for part B. So that is the basic idea behind factoring by grouping. Hopefully this video was helpful. Once again, the whole point of us going over these different types of factoring methods is because it's really going to be important when we talk about polynomials and graphing them in the coordinate plane. So this idea of factoring is going to be super helpful. So by the end of class today, I'm going to need you all to complete 4 of the following problems right here. So A, B, C, and D. I'm gonna need you to complete by the end of class today. And for each of these 4 problems, you're gonna factor by grouping. So once again, make sure you turn these problems in by the end of the class period on a separate sheet of paper. Feel free to work with your neighbors to help figure out the answers to these problems. Once again, the main idea is to be able to factor by grouping. Once again, if you have any questions, please feel free to reach out to me. I'm always here to help, and I hope you have a great rest of your day.